Hello, Chem 20s. It's me, Mr. Jukley. Going to talk to you today about percentage yield and percentage difference. This is currently page 9, and I believe it's page 10, and some of the practice spills over to page 11 of our workbook, but definitely starting on page 9. You'll notice with this that a lot of this stuff is going to start to seem redundant when we're talking about stoichiometry. Stoichiometry is kind of the same thing over and over and over and over and over again, right? And we've seen that in the first couple Stoic lessons. So anyways, when we're doing stoichiometry, stoichiometry can be used to test experimental designs, technological skills, purity of chemicals. Oftentimes when you see like crime shows and stuff like that, they're trying to figure out how pure something is, they're doing stoichiometry, well, at least in one way, shape, or form. Percentage yield is a great way to figure out, what is actually produced and compare that with what should have been produced, assuming that there's no errors. So what's actually produced versus what is supposed to be produced. So yeah, it's really similar to just calculating on an exam. It's what you actually got versus what you could have got times 100%. So when we talk about this in the lab, 5% is typically what we're going through. So we want to be within 5% or above 95%, in other words. There's a whole bunch of different errors that we could look at: measurements, equipment, purity of the chemicals, washing and filtering of the precipitate, qualitative judgments, so color when determining endpoints. We'll talk about endpoints soon enough. Human error is not one of them. So if you make a screw up, just go back and fix it. So don't say human error, oh, I spilled all my chemical, I'm just going to keep going and see what happens. Nah, that's no good. Okay, so formula is very simple. So percent yield is equal to what you actually got, so in your experiment, divided by what you should have got, so what you predicted is what we're going to call it here. Uh-oh, my felt pen stopped working for a second. Predicted times 100. So what you actually got versus what you predicted you should have got times 100. Now sometimes if you look this up on the internet, you see videos and the actual predicted kind of gets messed up a little bit. So predicted you also sometimes see as theoretical. Actual you sometimes see as experimental. So just know that there's other terms for this, but these are the ones that we're going to kind of stick to. Okay, so a couple quick examples here. So example number 1. Assume we calculated the mass of product to be 3.25 grams. In the lab, we ended up with only 3.01 grams. Okay, calculate the percent yield. So this one, we calculated the product to be 3.25. We did a stoichiometry calculation. We said we should be getting 3.25. That means this one is my predicted. And what I actually got in the lab, so I'm going to call that actual, is 3.01. So if I wanted my percentage yield, it's going to be equal to my actual divided by my predicted times 100, which is, so my actual 3.01 grams divided by my predicted 3.25 grams times 100. Let's take a second and plug that into our calculators. Let's see. I got 92.6%. And notice that we are still including significant digits with this. So that is not within our 5%, right? It's less than 95%. Cool, but that's all right. Sometimes things get lost in translation. Sometimes it's not quite pure enough. So yeah, 92.6% yield in this case. Okay, let's just check out this next one. Okay, so we've obviously talked about, for the first example, for this one, we've said, okay, maybe some of that product was lost somewhere along the way, or things weren't pure enough. Let's check out the next one. Assume the above question obtained a new mass, so this is my new actual mass, of 3.87 grams instead of 3.01. So we're saying not 3.01. What is the actual yield? Still assuming that the theoretical value or predicted value is 3.25. So in this case, it's going to be 3.87 grams divided by 3.25 grams times 100. And that, again, I need my calculator for this. Let's see, that works out to be 119%. Wow, 119. Could you think about what would happen to give us more than 100% yield? Right, so maybe if we're filtering and drying, maybe it's a precipitate that needs to be filtered out and dried. What if it wasn't totally dried? Then we'd have more. Absolutely. What if we didn't measure properly in the first place? We could potentially have more. Cool. So there are reasons and there are times when you get over 100%. Usually we end up with less than 100% yield, but not all the time. Okay, let's check out one more example, a little bit of a trickier one, but still 100% doable for us. So it says in a lab, 21 grams of methane gas is burned and it produces 45.9 grams of water. Calculate the percentage yield. Okay, so first off, this is what is actually produced in the lab, in the experiment. How on earth am I going to figure out what my predicted value is? If you're thinking stoichiometry, you're definitely onto something. And we remember the first step for stoichiometry is a balanced chemical reaction. So I've got methane, that's CH4, and it's a combustion reaction. So combustion, remember, is always with oxygen. And hydrocarbon combustion, nice and simple, always produces gaseous water and carbon dioxide. So the most simple oxides, and of course that's a gas. Now I got to balance it. So let's see, one carbon, 4 hydrogens. Oh no, only 2 hydrogens, so I better double that up. Let's see, now I got carbons and hydrogens balanced. I've got 4 oxygens on the products. So I need 4 oxygens on my reactants. Nice, okay, I've got that. Now next step in stoichiometry, at least the step that I like, is just to list everything out. So 21 grams of methane. And if we're trying to figure out my percentage yield and I know my product is water, well, I should probably figure out my theoretical or my predicted mass of the water. Now, in order to get this, we're going to need some excuse me, a couple molar masses. So for methane, that's 1 carbon and 4 hydrogens. So 12.01 plus 4.04, I think that's 16.05 grams per mole. And water, you know, I have this memorized from Science 10, hey? Water, the molar mass is 18.02 grams per mole. Nice, so we got all of our information summarized. Now I got to go through, I got to start with the one that I've got enough information to figure out the mole, so I'm going to go 21 grams of CH4. I want to figure out the moles of that, so I need to cancel out grams and end up with moles of CH4. So I'm getting my moles of what's given. And let's see, it's 16.05 grams for every 1 mole. Nice. Now I need to use my mole ratio to figure out the moles of what's required. So in this case, that's the water. So let's see. I've got nothing in front of the CH4, so that means I got a 1 there, and I got a 2 in front of the water. So first let's cancel some units. Moles of CH4 and moles of H2O. So there's a 1 in front of the CH4. Well, there's technically nothing, which we know is a 1 in front of the CH4. And then there's a 2 in front of the H2O. So moles of CH4 cancel with moles of CH4. Nice. Now I just need to figure out the mass of my water. So I want to go ahead and cancel out moles of H2O. I want to end up with grams of H2O. And I know it's 18.02 grams for every 1 mole. Perfect. Moles cancel with moles. I can go ahead and plug some numbers in. Let's see. You should be doing the same right now. I'm ending up with 47.2 grams of H2O. And again, that is my predicted or theoretical amount. Now, if I wanted my percentage yield, I just say percentage yield. Well, that's always equal to, I keep spelling yield wrong. Terrible at spelling here. But anyways, you know what I meant. Percentage yield is my actual, so in this case, 45.9 grams, divided by my predicted 47.2 2 grams, and then just to turn it into percentage form, we multiply by 100, and let's see, I believe I get 97.2%. Very good. That's a very, very good percentage yield. Nice. So that's really all there is to percentage yield. Like, that is everything that you would need to do for percentage yield. Don't go away quite yet, because there's also percentage difference or percentage error. Okay, so percentage yield talks about how well we did, right? How close to 100% we are. Percentage error talks about how poorly we did, how far away it is from that. The formula is actually quite simple for this one. So the formula that we look at is our percentage error, is going to be equal to my actual, so what you actually got in the experiment, minus your predicted, divided by your predicted again. So it's the difference now between what you got and what you could have got. And this sometimes works out as a negative number, so we just put an absolute value. And of course, if we wanted in a percentage, we multiply by 100. Now, there is another way to do this, right? You could also take, and I'll just show you this really quickly so you don't necessarily need to remember two formulas. You could also say, so if this is 97.2% correct, it must be 2.8% error, right? Because what you did and what you didn't do should add up to 100%. But anyways, two different ways to look at it. We'll check out both. Real quick example here. So calculate the percentage difference if 37.5 grams mass was determined in an experiment. So this one is my actual because it's in an experiment. And 47.1 was my theoretical, so this one is my predicted. So my percentage error is going to be equal to let's write the whole thing, is going to be equal to my actual, so that's 37.5 grams, minus my predicted, so that's my 47.1 grams, and then divided by that predicted again, so 47.1 grams, times 100 to get into percent form. Now when you plug this in, please do 37.5 minus 47.1, hit enter, then divide whatever number you get by 47.1. It might be a negative number. Who cares? Pretend it's a positive. Multiply it by 100, and we should end up with 20% error. 20%. I may have totally forgot about sig digs there, didn't I? Yeah, okay, so let's just have a quick look see here. 37.5 minus 47.1 by 47.1. 20.4 I think is a little bit better if I'm being totally honest with you. 20.4% with sig digs. Cool. Okay, so that's really all there is to it. The questions that you've got here, these questions are mostly percentage yield. And honestly, if you understand the idea of percentage yield, you understood from the last couple lessons the ideas of stoichiometry, do a couple of these and you're probably good to go. One thing I should kind of note with this is the questions are a little bit funky and the answers are a little bit funky in our data booklets. So it works out fairly well, but in our answer key booklets, but the answers are on page answer book page, let's see, it's 9 to 11, which I know doesn't correspond perfectly to the page numbers that we got here. I'll have to fix that one day. Anyways, that's it. Sorry for rambling a bit at the end there. We'll talk to you again soon. Bye, Chem 20s.